A small rock is thrown vertically upwards at a speed of 22 meters a second from the edge of the roof of a 30-meter tall building. A. What is the speed of the rock just before it hits the street? It doesn't hit the building on the way down. B. How much time elapses from when the rock is thrown until it hits the street? So to start off this physics problem, we're going to draw a picture. So here is the top of the building, and we know that the building is 30 meters tall. 30 meters. And we know that there's a rock. Here it is at the edge, and it's getting thrown upwards. And it's going to have a flight path that looks roughly like that. And according to the things that we were given, this initial velocity in the y direction is 22 meters a second. And we want to find time, and we want to find the speed as the rock hits the bottom. So let's do that. What's important to realize is we are going to need to break this problem up into two phases. The first phase, what we're going to do first is we're going to be calculating the time and the height that it takes to get to this point here at the top when the velocity is 0, because it's going to stop for a specific instant. And then our second phase is going to be this whole time period as it's falling down after it stopped at the top. So let's go ahead and do phase 1. Phase 1. Okay, so here once again is the top of the building. We've got the rock. It's going to do something like that. Boom. There at the top, it's going to stop. And as we know, this is 30 meters. Here's the building. And we're just doing phase 1 right now, where it stops at the top. So that tells us that the velocity at the top is 0, because it stopped. Here, we still have initial velocity in the y direction of 22 meters a second. So now let's write out what we have. So our initial height is 30 meters. Our final height is going to be the height at this point. Remember, we are telling our kinematics equations what we want to find. And by having our final velocity later equal to 0, we can find the height that the rock is at. And that's going to help us out in phase 2. So for now, we'll just put a question mark because we don't know y final. It's that right there. For the initial velocity in the y direction, they gave it to us as 22 meters a second. And we do know the final velocity in the y direction. That is 0. Boom. Acceleration in the y is negative 9.81 meters a second squared. And time, we don't know. All right, so let's get started. Some of you guys may have 4 kinematics equations. I was only ever taught 2 of them, and it turns out that in fact you only need 2 of them, so I'm just going to be using the 2, and we call those the short and the long equation. So let's start out. So we've got the long equation, y minus y naught is equal to initial velocity in the y direction times time plus 1/2 ay t squared. All right, let's see what we got. So y final, this here, we don't know, so that's this. Y initial, we know that is 30. We know our initial velocity in the y direction is 22. We don't know time. And we know that ay is negative 9.81. So boom, negative 9.81. That leaves us with something that looks like this. Adding this 30 over to the other side, this 30 over to the other side, we've got 30 plus 22t minus 4.905 t squared. Now we've got 2 unknowns. We can't solve this equation. So we're going to move on to the short equation. Vy minus Vy initial is equal to acceleration times time. We know that. Boom. And we know our final velocity. Here it is. Boom. Final velocity. That is 0. And our initial velocity is 22 upwards, so it's positive. We've got negative 22 is equal to negative 9.81 t. And that gives us a solution of t is equal to 2.423 seconds. Perfect. Now let's plug that in over here. Now our only unknown is y, and we can find the distance, this distance right here. Boom. From the bottom to where the rock stops, way up there. We can call that y, because that's what we're solving for. So plugging in t is equal to 2.423. We get y is equal to 54.51 meters. Perfect. And now we're going to be using this number right here, and it's going to be our initial y for our phase 2. I'll show you what I mean. Now let's draw out phase 2. Phase 2. So remember, phase 1 was this phase right here where the rock is thrown and it stops at the top. That means that phase 2 is going to be this represented in black here. After it stopped at the top until it hits the ground. That's going to be phase 2. So let's draw our picture. Here's the top of the roof or whatever. The rock is here at a total height of 54.51 meters. There's the ground. There's the rock. And phase 2 is going to be this right here. Boom. All the way to the ground. And the problem wants us to find the final velocity as it hits the ground and the total time. So let's write out what we know. We know our initial y distance is 54.51 meters. Y final, we do know it's 0. Our initial y velocity is 0 meters a second. That's because at this instant, the rock is stopped. So our initial is 0 meters per second. But our final, we don't know. We're going to find it. Our acceleration in the y is still negative 9.81 meters a second squared. And time, we don't know either. All right, so let's do the same thing. Let's do our short and our long equation. Doing the long first, we've got y minus y naught is equal to vy naught t plus 1/2 ayt squared. We know final y is 0. We know initial y is 54.51. We know initial velocity, 0. And we know acceleration to be negative 9.81. Perfect. So we've got negative 54.51 is equal to negative 4.905 t squared. What do you know? We can solve for t. So t for phase 2 is going to be 3.33 seconds. Boom, that'll be helpful. And then let's do the short equation. Vy final minus Vy initial is equal to acceleration in the y, which we know is still negative 9.81 times time. And we know that the initial velocity is 0, but we're going to solve for this one here. So plugging in 3.33 for time here, the t variable, we're going to get Vy is equal to negative 32.70 meters a second. Boom. That's one of our answers. This is A, because A asked us for the impact velocity, and B asked us for the total time. So we're going to take the time it took in phase 1 to reach the top, 2.423, and the time that it took to go from the top to the bottom. And we're going to add those together, so T total is equal to 2.423 plus 3.33, which equals 5.753 seconds. And that is the total time that the rock is in the air. Sweet. So it's super important for a problem like this where you have an object being thrown up and it's stopping at a certain point. It is super important that you break it up into two phases. Otherwise, these equations are going to fall apart and they're not going to be able to work. It is vital that if you're going to use this strategy of kinematics, that you do this. And I find it super helpful to draw pictures like this so you can totally see what's going on, and always write out what you're given, because then you can just plug all that right into there. Cool. Thank you so much for watching. If you liked the video or if it was helpful, drop a thumbs up, and we'll see you next time.